everyone. I'm Litao Lin, and today I'm here to deliver a workshop about named entity recognition. I will introduce about named entity recognition theory and its application. And I studied in information library and information management. And the named entity recognition technique is a very important skill to do knowledge organization, and it is also a very important tools to do digital humanity research. So today, this workshop is not you need some computer science basic knowledges for this workshop. It's not very suitable for very beginner, but it's okay. I will explain it in detail, but you don't need to put too much stress on yourself. Although the knowledge is basic, but I know it's still a little bit difficult for a very beginner. So I hope you'll keep it in mind. Just take it as a very general introduction. So let's begin with the definition of named entity recognition. A named entity is a term that refers to a real-world object that can be uniquely identified and classified within a specific category, such as person, organization, location, date, or numerical expressions. And the point is, named entity is a term that in a text is not a real thing. And the entity is a real thing, it's a real objective in real world. And the named entity is just a term, or we can also say noun-phrase in text. And the named entity recognition is a process in natural language processing. And the goal is to locate it and classify named entities in a specific text, to classify them into a predefined categories. And here I would like to give you an example. And as we can see, here is a sentence. Let's take a look. So the sentence says, the logo of Apple Inc., founded by Steve Jobs, is an apple shape. So in this sentence, we have three named entities, and the two of them are used the same words, which is apple. And the first apple, you can see it refers to a company. But the third apple, it refers to a fruit. And the first line, we call it tokens. We can split the sentence into tokens. And the second line is the index of each token. And the objective of named entity recognition is to locate the named entity in a given text and classify the specific tokens into predefined categories. And in this case, the predefined categories includes company, person, and fruit. So we can, if a model identifies the word apple here into a company, which means it make a mistake. So we need to both identify the correct index of a given of the named entity in a sentence, and we need to classify it correctly into a correct predefined categories. And here I show you the ideal output, ideal result of the named entity recognition, which is in JSON format. We have the big brackets, and we have the name of each item, and here it's the original sentence. This is original sentence. The Apple logo is an apple shape. And here we have the recognition result of named entities inside the sentence. And here we have another bracket, and we have several big brackets inside, which are also in JSON format. Here we have the text of the raw text of the named entity in the sentence. And here we have the correct type of the named entity. And here, take a look, we have the correct index of the named entity in this sentence. And here we can see that the index is 3, which means it's the fourth token in the given sentence. And I would like to say a few words about the word token. And token is the official word in natural language processing, and it means the subunit of the word. And here, but for most of people, you can consider token as a word. You can take tokens equal to word. And here you can see with the comma is not a word, but so we cannot. So it's more precise to say the comma in tokens, not say it in words. And why would we do named entity recognition? Because if we want to organize unstructured text with ontology technique, we need to extract the knowledge unit from the raw text and organize it into a more formative way. So by using named entity recognition, we can refine the raw text and make it more sufficient to readers for knowledge organizations. And here I would like to give a brief introduction about the evolution of named entity recognition. We can divide the method of named entity recognition into 3 categories. And the first practice is called rule-based methods, which means we can use regular expressions and or dictionary matchings to identify the named entities in a given sentence. And by using rule-based method, we don't need to train any deep learning model or machine learning models. We just to make some rules, and we need to prepare some dictionaries, and we do the dictionary matchings based on the rules we created. But here, if we use a rule-based method, there is a high requirement for the knowledge you possessed about the domain of the text you are about to do named entity recognition. If you don't make a very exquisite rule, you cannot extract all the named entities inside the raw text. And here I gave an example. I gave an example about what is rule-based method, and it is realized in Python language. Here, the objective is to identify the noun phrase that express the date in the text. And here we have the text, January 1, 2023, and February 2, 2024. And here is a method that combines regular expression and the dictionaries. Here we have the dictionary of the spellation of all the months in 1 year. And here is this part is a dictionary. We can consider it as a dictionary, and this part is the regular expression. And by constructing this pattern, we can identify all the noun phrase or named entities inside the sentence which match the pattern. And the advantage of this rule-based method is it is very simple and effective. But the method is not that general, which means we need to make different rules for different domain of text. And here I would like to introduce another 2 type of method for named entity recognition. And the first one is called statistical machine learning method. And there are some very typical algorithms that to do this job. And one of them is called conditional random field. And the other is hidden Markov models. And I would like to give a detailed introduction about this method. And the third method is called deep learning based method. And the biggest difference between this two method is the algorithm behind the method. When we talk about deep learning based method, it means we will use neural networks. But in the statistical machine learning method, we just use mathematics. We just use mathematics. We don't use neural networks. But both of them is kind of a probability model. We calculate the co-occurrence of each word in a sentence to construct the pattern of the corpus. And for deep learning based method, there are some very popular architectures, and one of them is called back-directional long short-term memory and plus CRF. And the other is called BERT model, which is kind of famous. And also we can combine the BERT model with the bidirectional long short-term memory and CRF. And these two type of method require us to prepare our own corpus, and we should import our corpus into this kind of model to let the model learn the patterns of the co-occurrence of each word. And then we can use the model to make prediction, to do automatic recognition to unlabeled data. So some people may have this question. I don't want to learn the algorithm behind the every model. They are too complex. So is there a convenient way to do named entity recognition? And the answer is yes. And here I listed some of the very famous open source NLP tools, which can do named entity recognition. For example, the SPACY and the Core NLP. And Core NLP is developed by Stanford University. And this is SPACY is also a very famous NLP tools for industry implement. And NLP is NLP tools especially for Chinese text. And here, Stanza is also a NLP tools developed by Stanford University, and it's more focused on English text. But this may still not enough for us. Because the open source NLP tools like SPACY, Stanza, and Core NLP, if we want to use them to do named entity recognition, it can only recognize the very common or general named entities, such as company names, person names, and the date and place. These are very common. So if we have a very specific corpus, we have our own corpus, and the named entity we would like to recognize, they are not predefined in this kind of open source tools. How can we do that? How can we automatically recognize all the named entities in our own corpus? So that is the reason why we should train our own models to make unique models to make it suitable for our own corpus. And nowadays, one solution is to train our own models, and the other solution is to use large language models. Large language model is very powerful. It has a very general usage. It can do a very wide range of NLP tasks, but it is not that very precise for some very Asian texts. So I would like to start with training our own models in a very basic way to teach us how to the basic plagiarism for deal with this problem. So here, let's take a look at how does typical NER models work. And here's some background knowledge. Named entity recognition, word segmentation, and part of speech tagging, and text segmentation. They all follow a natural language. They all follow the same natural language processing task paradigm. It's called sequence labeling. And we can say it in other words. That is any model that can perform named entity recognition can also perform tasks such as word segmentation, part of speech tagging, and the text segmentation, because they obey the same law. So what is sequence labeling? And here I prepared an example to explain this problem. A sentence can be considered as a sequence of tokens, just as I showed you in the second slide. And here is the same sentence that I showed before. And we can consider the sentence as a sequence of tokens. That is what sequence means. It is a sequence of tokens. And the sequence labeling means we need to give each token a predefined category. And here, for example, in this sentence, we have 3 named entities, and Apple here means it is a company. And when we do sequence labeling, the ideal result is to identify the apple with the label of company. And here we have the Steve Jobs. It's a person name, and the result should be we should give each token the classification of person. And it's the same with the third apple. And this column, the first column is the index of the tokens in a sentence, and the second column is each token in a sentence, and the third column is the corresponding label of each token. And the sequence labeling means we should give each token in a sentence a correct label. And this is a very classic schema for doing named entity recognition. And the letter O in this case means tokens which is not a part of named entity. And the label B as a prefix, it means the beginning of a part of named entity. And the letter I means the token which are the rest part of a named entity. So if we get a result that seems like this, it means Steve, it is a beginning word of a named entity in the categories of person, and Jobs is the second word of a named entity. And once we have the result of the labels for each token, we can reconstruct the sentence, and we can know where is the named entity and what is the classification of the named entity. So that is the basic principle of how typical named entity recognition model work. So what is the process of training a machine learning model? Here we have 5 steps. The first step is to create some manually labeled corpus for training. And the second step is to convert the raw corpus into the sequence labeling format, because our machine learning models can only recognize the data in this format. And the third step is to separate the corpus into 2 parts. which is training data and test data. And these two parts of data set, they are not joined. They are totally different. They cannot cover with each other. They are totally separated. And the fourth step is to deliver the trained data set into a machine learning models. And the machine learning model, the algorithm behind the model will learn the co-occurrence pattern of each word. And after training, we will get our own model that's suitable for our own corpus. But it's still not over because we are not sure whether the model is adequate. The process, we don't know. We don't sure if the precision and the recall is adequate enough for practical use. So we need to test the performance of the model we have trained. So test evaluation of machine learning models is the final step. And for named entity recognition task, we evaluate the performance of the model in three metrics, which is precision, recall, and F1 values. And nowadays there are so many types of machine learning models that's suitable for sequence labeling tasks. So we may have the question, how to choose machine learning models for our own task. And the answer is we should choose a model based on the characteristics of our own corpus and our task objectives. And it is not the case that more advanced the model, it is not the case that the more advanced the model, the better the effect. The reason is many advanced deep learning models are designed for modern text processing, and they are not very efficient in processing Asian corpus. And if we have a very complete named entity dictionary, and in this case, use a dictionary-based method is more suitable than training a model. And even though nowadays we have many deep learning models based on neural networks, and some machine learning models, statistical machine learning models are also very useful nowadays. For example, CRF is one of them. And in some Asian texts, conditional random field is more efficient and precise than the deep learning models. And here I presented an exercise for doing some practical experiment with CRF. And by doing this exercise, we can know how the sequence labeling paradigm work. And now I would like all the attendants to open the Google Drive that I prepared for us. There's some enter into the CRF folder. And we can take a look at the example data first. Here we have the example data in English. And we can open the entire folder with VS Code or any other kind of text editor. And here we can see the format of the raw text. It is already constructed into sequence labeling format, which is the first column is the tokens in raw sentence, and the second column is the corresponding label for each token. And here I simplified the plagiarism. We only have one type of named entity, which is non-phrase. And if we apply this model to our own corpus, we can change the label here into other into other tags such as person or company or fruit or place, whatever you want. But here I just make up one type of tags, which is non-phrase. And here is the training data, and here is the test data, which is in the same format. And here we separate each token and its corresponding label with space, with only one space. And here, this is one sentence. This is the token of only one sentence, and each sentence is split by a line. Each sentence is split by a space line. Yeah, and we should, after we labeled our own data, we should convert our corpus into this kind of format. And this is, and how to convert it, I will teach us later. Now we have know the format of the raw corpus, and let's start with CRF. Let's see how it used. And here I would like you to open the command prompt, the terminal. And if you use Windows system, you can open it here. The command to enter into the path, which is C, D in lowercase, and left slash, and lower class D. And then you paste your absolute path of CRF folder here. And you can get inside the folder in terminal. And here I already prepared the command for training and testing the model. We press read media MD here, .md here, and we can see the command. And I also write the meaning of each command. Okay. And let's take a look at the command. And here we have the command of training models. There are some parameters inside, and I will explain some important parameters. And this is for the thread, which means how many threads you will call for your computer to do this job. But it's not important. But the rest part is the path of the training data. And the template. The first one is the template. If we use CRF model, we need a template to tell the algorithm that how to identify how many words we should look up at once. For example, we should look up 3 coherent words or 4 or 2. And the last part is, and the third part is the path for our training data. And here we have the data folder and the folder inside, which is example EN. And here we have the file, the train file .txt format. And the last part of this command is the output path of the trained data of the trained model, and we will have our trained model here in the which means in the folder of output and with the name of example English model. And I already established the folder here. And as you can see now, this folder is currently empty. And now we need to copy the command, copy the first command. Copy the first command. Okay. Yeah, copy the first command and go back to our terminal window. Copy the command.
Yeah.
And go back to the terminal window and paste your command here. And press enter in your keyboard, and it will start training. It means they are learning the co-occurrence pattern of each word in the corpus.
Wow.
Yeah, it worked. Here is NPR.
Yes, yes.
Yeah, no, my friends they were doing it together because he said that he was not working, but I can try if it works.
So Sylvia, did you success?
Yeah, yeah.
It's the same result.
Yeah.
Okay, that's good. Fantastic.
Yeah.
What about you, Rachel?
Yeah. I'm so.
Did they start training? Yeah, it means if you got the log of this kind, if you got this kind of log, it means you have already trained the model successfully.
What about people online? Any problems, any issues?
2 minutes ago, the output folders has nothing, but now we have a new file. It is the already trained file. It is our own model. Successful. It means you succeeded.
I got something.
And the next step is to evaluate the performance of our trained model. And here let's back to the command lines again. And we go to the step 2. And it's the same practice. We copy the command and paste it into the terminal window and launch it. Yeah. Launch the command and it will finish in a second. Launch command. Yeah, and we can go back to the window and check the output folder, and we can get another new file. And we can open the file to take a look at inside. And here, let's go back to the first command. This means the path of the training data. And this suffix, it depends on the format of the, it depends on the file's name of your own corpus. It doesn't matter if you use TSV or TXT. Yeah, just write the same file name here according to your own file name in your computer. And here, let's go to the step 2. It means we will call the interface, we will call our trained model. We are already trained model. You see, this is the road path, which is exactly the same with the one with the previous one. And we will call our trained model, and we will apply it to the test data set. And here is the road path, is the path of it's the relative path of the test data set. And here it means we will output the result into another new folder with another new file name, which is example English output.txt. And I also paid the link of the website of the package in PowerPoint. And actually, the corpus I used here is the official demonstration corpus that provided by the original author. And let's go back to the out folder. And if you got the second file, it means you and you open it. And if you see 3 columns, it means you already successfully applied your own model into the test data set. It looks and the second column and the third column, it looks very similar, but it's not. But it's not the totally same. And you may wondering what is the meaning of this file. And let's make a comparison with the test file in the data folder. And you can see here the raw test.txt file, it has only 2 columns. But here in the output folder, we have 3 columns. Okay. Mm-hmm. Yeah, and let's compare the first column. It is completely the same. And we have 1972 lines in the raw test file, and we have the same number of lines in the output of test file. Yeah, the biggest difference is the new file got 3 columns, got another 1 columns. And this column is the prediction result of our untrained model. And here you can see there's a difference between the second column and the third column. And the third column, the label in third column is the prediction result of our trained model. And if we compare the difference between the second column and the third column, we can know the performance of our own model. Yeah, if the second column and the third column are the same, it means the model make a correct prediction. Mm-hmm. And here we can see it make a wrong prediction for the first line. It should be the word confidence should be the beginning word of a noun phrase. But the prediction of our own model, it identified as a as not a part of a noun phrase.
No, it's fine.
Okay.
Thank you.
Yeah, and let's calculate the precise index of the precision and recall. And here, let's go back to our command file, which is here, readme.md. Yeah, I listed all the command there. And let's go to step 3. And yeah, if we launch this command, we need our computer already deploy Python environment, because this algorithm to calculate the precision and the recall, to calculate the metric is based on Python. And we copy it. It means we use Python language, and we call the interface of this file, and then we give this file the output file's path, and this program will produce a new file with the classification with the index with the matrix of the evaluation into another folder. Yeah, and this is the file's name that with the result of the matrix of the evaluation. Yeah, we copy this command and go back to our command windows. And we paste it here and launch it. And here we go back to our Windows. In the out folder, we will get a new file, and we double click it. We can see the result of the evaluation. Yes, correct. Yeah, and now we have know the evaluation result of our model, and it has the result of it has the precision of 78%. And if we think this performance is already adequate enough for practical use, which is not, but we can assume it is already enough for practical usage. We can apply this model to unlabeled corpus. And here I have the unlabeled corpus, which yeah. If we want to use it to unlabeled corpus, we just need to put all the labels here to any kind of labels.
Just say so bad. Can you say it again?
Okay. Yeah, it's the same operational with testing the model.
Okay, so we go to the label. We choose.
Okay, you don't need to change anything. Let's go back to the command line. README file.
Okay.
Yeah, and we copied the last command and paste it into the terminal window and launch it. And we will get another file.
Step 4.
Yes.
In the out folder. Here.
Okay, let's yeah. Yeah, just take a look at my screen. I just changed the labels, all the sequence labels in the unlabeled file into letter O. You can see this is the before and this is after. Okay. We can replace them, all the labels into O.
Yeah.
Yeah, and this is a demonstration of unlabeled data. Yeah, which finish the exercise with conditional random field. And here we got the result like this in 2 columns with the prediction result, but it is not human readable. This format is not human readable. And if we want to do further research, we need to convert this format into the natural language format. And here is the one reason why we need to convert the sequence labeling format into a natural language format. And the other reason is, no matter what type of machine model is used, it is very difficult for them to achieve 100% precision and recall for the prediction result. So we need human profiling and correction for the predictions. If we want to build knowledge base, we cannot allow there are wrong statement in our knowledge base. So we need to correct the result of the prediction. Okay, I think is it right? Oh, this is right.
Here it's right. Everyone is also into this one.
No, it's fine.
Shall I continue?
Yes, please continue.
Okay, and here let's begin with how to convert this format into this format. And we have another exercise for using an annotation tool called Inception.
Yeah, we asked ChatGPT. Yeah.
Oh, the rest of the part don't need Python environment.
Quite just. Yeah, but we don't have the file to upload.
Yeah,
To go to the reception.
Yeah, I prepared it. You don't need the file. I prepared it in Google
In the
Drive.
folder?
In Google Drive.
Okay, fine.
Okay, let's begin with the exercise 2. And here we have the example data for Inception. We have this folder, and I have prepared some data. And here in the second, in this folder, which it has once we start the inception, we should not close the terminal window. Just keep it minimized, but not close it. If we see this URL, it means we have already initialized the Inception program, and we press Control in our keyboard and left click this URL, and it will open the window in our web browser. Yeah, and if we are the first time to use the Inception, it will need us to create the administrator's account, and we just need to randomly set a password. And here we have into the main window of the Inception. And here we can click the first option to create a basic framework for annotation. It has a universal usage for both named entity annotation and for named entity relation annotation. And if you don't have this window, just click create a new project. And our goal is to make a correction about the prediction result of the CRF model, so we can give the project a correct name, a suitable name. No matter what you want, it depends on you. And now we press setting here. We need to upload our file for annotation. Here and click documents. Click documents, and now we can browse our file. We can, let me show you. Here we have the example data for Inception. And choose this. Yeah, it's
import here.
okay. Let me give you a brief explanation about this file. Yeah, and let's take a look at the output of the CRF file. You see in the CRF file, we have 3 columns, right? And the third column is the prediction result. Yeah, and if we want to upload this file into Inception, we need to firstly upload this file into Excel and delete the second column. But we don't need to do that because I already prepared the processed corpus for us. So if we want to use the result of the CRF model, we upload it to Excel and delete the second column and keep the rest of it. And we will get this. It's exactly the same with this, but without the second column. And now we choose files to import. And here we choose this file, prediction dot conference of NLP. Yeah, this file, prediction column. Yes, it's abbreviation of conference name, but it doesn't matter the suffix of the file. You can change it into any suffix you want. You can change it into txt, or don't keep any suffix. It's okay. And you just press here to upload it. And here we should choose the corresponding format of the file we are about to upload. And in our case, this file with 2 columns is called the format of TALOS-AI 2022. 2002, yeah, sorry.
Some example or the other?
Example.
Example.
The second one.
Output.
Yes. Yes.
So input.
Yes. And it shows the corresponding format of 2002.
Okay. Has it done?
No, you
no,
have
no.
to show the. Yeah, choose the corresponding format. Yeah, and then press import. And this is exactly the prediction result of conditional random field model. And we go back to projects up here. Okay, go back to project. We go into our project and we press annotation. Yeah, and here's the file that we can do annotation. Yeah, there's something not in our not as our expected. You see, there's no prediction result here, right? Yeah, and I will show you. Yeah, I show you this page is because I want to explain to you the next meaning of the operation. So we need to do something more to make the prediction of the self model visible. So we need to go back to the project setting again. And we press here. Setting and go to settings. And go to layers. And here we need to add some predefined layers in Inception to make the prediction result visible. And here we press 8. And here they have predefined frameworks for different type of NLP task. And for our case, we are doing the named entity recognition. So here we can find the framework of named entity recognition. So we click this
Which one? Tagging.
Tagging, yes. Now we have a new layer. It is a predefined layer. So we have the layer of named entity tagging now. And we press 8 again, and we will find there's a, and we can only edit the same layer for one time. And once we edit the layer of named entity tagging, we cannot see the option anymore in the list. And here we have the features. And here we can set the tags, for the named entity tagging. It's a little bit complex. Yeah, and now we should go to the tag set at the left. Yeah, and here we have the tag sets. And we can see there are some predefined tags in the list. And if we want to add our own tags, we can press create here and add our own tags.
You added something else? Or that's press that again. Oh.
Here. Yeah, here's the predefined text, and you can add your own text. And you can also choose this option to make a correct on this option. It means it will allow you to create your own text during your annotation. Otherwise, you need to define your text here before your annotation. If you press this, you can do it when you're doing the annotation. And here I can create a new tag called time, just for example. And we save all the settings. And we go back to our project. Finish?
Yes.
You didn't create your own tag.
No.
Okay. Yeah, and go back to our project and press annotation. Yeah, and yeah, and here the prediction result of the CR conditional random field model, they are visible now. Yeah, and we can, if there's something wrong with the prediction label, we can change it. If we want to change it, we just need to double click it. Sorry, just one click. Yes, yes. If your device got stuck, then just refresh the page. Yeah, just like mine. I need to reboot it. Okay, for example, if this, let me refresh it. Yeah, and if this non-phrase is It's a false prediction. You can change it. You can manually change it by right click it, and here you can choose the correct tag in the scroll box.
Yeah, I could time just.
Yeah, just click it.
That's the rule.
No, you can. There's you can randomly choose one.
And then how to?
Yeah, and here you can change another tag.
Yes.
For example, here is oh my god,
It's lagging, huh?
it's stopped.
Oh. And we could also change which tokens are included.
What?
Which you can also, let's say, change which tokens are included.
You mean the index of the token? Yes.
Yes, the starting and the ending.
Yes,
index
yes,
of
we
the-
can change that. I will restart my web browser.
Yeah, sure.
When
Don't worry,
we
these things happen.
again, your screen sharing to solve the computer. But if we want to assign a new, we just or we just press. What do we do? So we say we want side. We just double click.
Just one click.
Okay.
Here, for example, it's a corporation's name. It's a company name here, and we can change the tag from non-phrase into oh my god into companies. If there's such kind of tag, and if there's no such kind of tag, we can define our own tag. Is it the word?
No, it says cannot set future.
Oh, you didn't. Here?
Here. In the tags.
You can change the tag. Assume it's a false prediction. You can change it into a correct one. And here you can press the tag's name. Oh my God.
It's company. What company?
Yeah. Oh my God. Press, okay.
Yeah, I got it. I changed here, right?
Yes.
Yeah, I just changed it. Just let's. Yeah.
Make sure this option is activated. Oh, okay.
Still lagging, huh?
Yeah.
Don't hesitate to restart if you have to.
Okay, I will restart my Inception.
We need to start the whole.
I cannot even control my mouse now.
Yeah, but you can shut down completely and restart. Don't hesitate.
But it will take a long time to reboot.
You can close some windows,
Yes.
many windows open, not terminals, not that many.
Just one more exercise, right?
Yes,
One more exercise.
there's another one, last one.
The last one.
This is not the last one, there's another.
Okay.
We have 10 minutes, but I'm super late for sometimes. We
Yeah.
can take maybe more 5 minutes.
Okay.
So there's a
Make
15
another 10 to 15 minutes.
Yeah,
we can take.
yeah.
Yeah, here we can change the label into, yeah, here is the name of a corporation. And we can change the tag from non-phrase into a more specific one, like a company. Yeah, and if we want to change the index, for example, the starting index and the ending index of the named entity, we just need to delete it. And press our mouse left button and drag it to the right index.
So you have to, let's say, delay the annotation.
Yes,
to
yes.
the new one in that sense. And can you overlap?
Yes,
I mean, I can imagine you can
it can overlap, but you can set some restriction on the coverage of the overlap. And after you after you make correction for all the prediction result, and you can export it into this kind of format. And if you choose this format, Cornell 2002, which is exactly the same format with the file we uploaded, and we can do the training again. But here I would like to, yeah, if we want to do further, we want to import it to another database, we should choose this one. This is a more complex format, but it has more function, and it has a tutorial from the Inception, author of the Inception, about teaching you how to use this format. But I don't have enough time to show you today. And the next exercise is about how to do semantic annotation based on ontology with Inception. And here I would like to mention that there's a algorithm inside the Inception which can automatically learn your pattern of annotation and do the automatic prediction on the unlabeled data. here is the the page that you control how the algorithm work inside the Inception. It will allow users to do semi-automatic annotation. And here, let's go back to our setting page. And here we can see there's a knowledge base function, which allow us to upload our own ontology and do semantic annotation based on the ontology we created. And here I would like to use the ontology that created by TALOS team as an example. And I already prepared the ontology into the folders in Google Drive, which is here. It's an ontology about Arctic oratory. And the first thing to do is to set a name for the ontology we are about to upload. Yes. And here we should choose the source of our ontology from local file. And here we choose the path of the ontology on our own computer. Is everything okay? Did you finish?
Yeah,
Copy the name.
Instead of local remote Spark.
And then next.
Next. Yeah, and then we press next. And here we can choose the schema of the of language. We can keep it as default, and we press finish. And here we can see there we already uploaded the ontology. And here we need to go back to the layers. And we need to add another new layer, which is called named entity linking.
Sorry, Litao,
Add
okay, when you were here, we
And
had
the
to
last one.
the last one.
Last one.
The named entity linking. If you
Okay.
already chose it, it will disappear. If you cannot see it, it means you already chose it.
Okay.
And choose the identifier. And here we can choose the ontology that we just uploaded.
Name entity. Wait, Litao, name, you are in name entity?
Yeah, in named entity, and press save in the middle of the page.
Okay.
And then you will see an identifier appear in the feature box.
Here.
Okay.
Yeah, and scroll down and you will see knowledge base.
Okay.
And here you can see the ontology that you uploaded. And you press save again.
Save here. Huh?
Yes, yes. Yeah, and we go back to the annotation page. And the annotation page.
Here.
Okay.
Right. Right, that's okay.
And on the right side, we can see the identifier box. Yeah, we don't have this before, but we have it now. And then press the icon of a tree map. Yeah, and then we can see the concept in the ontology, and we can allocate the concept inside it to the text, to the name entity in our corpus.
Oh, you didn't say it. It's very interesting. You didn't choose it.
Save here. The identifier correctly. Yeah, because you think.
And we can also choose the concept or the instance inside. And it will allow us to give a URI for the name entity inside our corpus. And if we hover our mouse on the name entity, we can see the URI. But there's a small problem, which is it didn't list all the classes in your ontology. Did you find that?
I think, well, it has all the classes that are in the ontology that you downloaded. Yeah, that is all of them, I think. From what you, when you briefly showed it, it looks like.
Yeah, you see here we have only 2 classes, right? But I uploaded your entire ontology. But here it only shows two classes in your ontology. But your ontology has more than that.
Yes, it does. Yeah,
Right.
if you click, all the classes appear. Go up, all the classes are here.
Yeah, maybe not all the instances.
Just, but it's different from what we saw in
sure.
Protage.
Yeah.
Yeah, sure, of course.
Nice.
It still does not show here. I don't know why.
Oh, we didn't click to kind of instances.
Yeah, because when you choose knowledge base, you can have it be just concepts, like just classes,
Yeah.
or instances and properties as
Yeah.
well.
Oh, no, it worked.
But it's very interesting that you can access it.
I think now it's okay. Yeah.
Thank you. Ontology, like, Inception.
Yeah, yeah.
Yeah, you can add new classes in Inception.
And we can, and now I opened the ontology, the same ontology in Protage, and you can see it's different. We only have this, I'm not sure what I don't know.
Those ones are from Teddy, and I believe they don't have labels, and I think in Inception it needs to have already has labels.
Okay.
to show up.
Yeah.
At least that's what I read about it.
If you press concept, press You see there are no annotations here.
Yes,
They
yes.
have RDFS. But I think if you put RDFS label and something, it should definitely appear. Because everything is here. Everything is here is labeled. You see the identifiers here are all labeled.
So if you were to add an annotation on that like lexical concept right now, just like add RDFS label lexical concept and then re-upload it into Inception, it would show up. It's
Oh,
just,
That's
Yeah.
great. You know the
Yeah.
solution. I don't know the solution.
Yeah.
That's
I was
great.
I was doing this morning,
Yeah.
actually.
You succeed.
Yeah, it's for some reason,
needs the
it
label.
only, it needs a label.
Okay, there's no problem. now.
No, there's no problem.
I think maybe we could wrap up shortly and close the Zoom, unless there are people who have questions from the Zoom room.
Okay, that's the main content for today's workshop, and it's a basic instruction about the entire framework of doing name identity recognition and make correction and semantic annotation with ontology. Yeah, and if you want to continue into this area, you need to dive into today's topic, and I will paste all the related links into the PowerPoint and into Google Drive.
Okay.
And let me finish.
No, sorry.
There's a and here is also an open issue. There is an open issue on GitHub about the problem you may occur when you do the semantic, doing the name identity linking. So you can take a look at this if you occur some problem. And I would like to summarize today's workshop. And what the most important thing is the entire workflow. Yeah, the most important thing is the entire workflow, not a specific model for doing name identity recognition. Yeah, you need to create a data set and train your model and evaluate your model, and then apply your model and then make correction about the prediction result. And the final step will be export the annotation result into external data set. And it's not always the good, not always the best model. I mean, we should choose our model depend on our objective of task and the characteristic of our corpus. We don't need to always choose the most advanced model. Yeah, and that's all the content for today's workshop. Thank you for your attention.